Hey, we're live. Excellent. Wonderful. Oh, goodness. When I was I think I was in college, every April 1st, I would always go online and immediately begin looking for what websites had done in order to try and fool people. Because you always knew that like these websites would like come out and do stuff all the time. In fact, I didn't even check Wikipedia today. Wikipedia usually tries to like throw up a bunch of dumb articles, but now I'm just kind of interested into what it says now. Hold on. Let's see. Wikipedia. Okay. Groundhog's Day. Yeah. Did you know the Cosmic Cthulhu has run for president in every election since '96? Okay. John. Wow, that's wow. There's a lot of inappropriate stuff here. Are any of you reading this? There's a lot of inappropriate stuff here. What's the deal, Wikipedia? Go away. Anyway, start my actual deal thing. Here we go. Get rid of that, and get rid of that, and get rid of that. Here's my goal for today. Yes, it's right before break. I don't want to introduce brand new topics today per se, but I do want to backtrack a little bit to what we were doing with t-testing. We started doing some things with t-testing several class periods ago. We took a little break to do a multiple choice inventory, which I'll talk about in a minute. But I want to take part of today and just go back to t-testing and fill in some of the gaps that we may need to do in regards to the procedures, in regards to the calculations, in regards to the conclusions that we can make in regards to t-testing. In regards to your multiple choice inventory for the past couple of class periods, I am going to be asking for those scores. I completely forgot to post that thing on Google Classroom. Again, it's not for a grade. It's more along the lines of, I just want to know where we're at. So at some point today, I believe, I am going to throw something on Google Classroom requesting the results of that multiple choice inventory that you took up to wherever we got to. And I will also provide for you the answer key for all of the questions on that multiple choice inventory. Again, not everything we've been taught yet, but we will get there. What I'm going to do in a moment is I am going to post a PDF to your Google Classrooms. And there are going to be some questions on that PDF. Those questions are what I would like to focus on for today. Now, what I'm going to ask is that whatever we end up doing with these problems, that you have some kind of a record of it in your notes. So I am going to ask that the responses that we put together in regards to these questions, that you do write them down because they are good for reference. Of course, I'll give you the reference for the PDF and whatnot, just so you can always reference the exact questions that are happening. If you are in the chat, if you are in the live chat, please make sure that you have left a comment. That would be phenomenal and wonderful. Here we go. And here is the PDF for today. Post. It's posted. There we go. Boom. The PDF looks something like this. It's a 2-page PDF. It starts off with a bunch of multiple choice questions. We're not actually going to talk about those today. I really wanted to focus on the free response questions, numbers 11, 12, and 13. We're going to start with number 11 right here. I wanted to walk you through the need for t-testing and what would actually happen as a result of performing certain things with t-testing. It is the beginning of April. We have, oh man, where's my whole thing here? A month and a few weeks. Probably a month and 3 weeks or something like that. There you go. A month and 3 weeks until our actual AP test, because that thing was pushed back a couple weeks into May. Go away, March. You're dead. There we go. Haha, that's cool. Yeah, get in there. Is there a day in April after spring break where you guys don't come in? Hold on, I could have sworn. April 19th. According to this calendar, I got this calendar the other day. April 19th, it says staff PD day, no students. Let's see if they change that. I don't know if they will, but we'll see. Anyway, this is where I'm going to be starting. For those of you in the chat, of course, this PDF is now available through your Google Classroom, so you don't have to strain your eyes at the screen. Let's start with number 11. The distribution of the number of vacation days per year offered by different U.S. companies is skewed to the right. Okay, again, just visualizing this in my mind. Just want to think about it being skewed to the right. If it's skewed to the right, that means the tail is to the right. Okay. It looks something like that, just kind of in my mind. We collect data on the number of vacation days from a random sample of 60 companies across the United States. Okay? 60 companies, 60 is large enough. Random sample. It can be inferred. I'm going to write some of this stuff down in a little bit, but it can be inferred that is it vacation days offered? Vacation days offered from company to company are independent of each other. That's reasonable based on the random sample. Again, I like to try to figure this stuff out as I'm reading the problem, just because I like to compartmentalize and be able to write things down for later. Why is it okay to use these data for inference even though the population is skewed? Now, this is part of the conversation that I wanted to have today. The data is skewed. We're doing t-testing for this problem. I know for a fact that we're going to do t-testing for this problem because I told you we're going to do t-testing for this problem. With t-testing, there were certain assumptions and conditions that we needed to make sure of before we were to continue, and we were allowed to use a t-test. Now, specifically for t-testing, what were some of those assumptions and conditions? I believe there were 4 major bullet points that we wrote down 1, 2, 3 class periods ago. So it's been a while. What would be an assumption and condition that we would need to hit for this information? Definitely random sample, which they told us. We'll take their word for it. What else? Yeah. Independence, which we did talk about. It's reasonable to assume independence from company to company in terms of the, I can't even think of it, vacation days. Couldn't think of the word. Vacation days that they offer. What else? Yeah?
Nearly normal.
Nearly normal. Now, that's going to be the tricky part. That's going to be the tricky part. Nearly normal. There's nothing in this problem that says it's normal. In fact, they go out of their way to say that it's skewed to the right. But clearly, there are other questions down below. They're assuming that you're going to continue doing something. Now, under most circumstances, if we were to confirm nearly normal, we would need to look at a histogram of the data. But we don't have that. Here's the one little tricky thing that I'm going to say, and then I'm going to go to my notes and actually write out this problem. T-testing occurs when you don't have the population standard deviation. T-testing can take place when your sample size is not large enough, as long as your data is nearly normal. The large enough sample size is not a condition here for t-testing. But is it fair to say that this sample size is actually large enough? It's 60. The sample size is 60. This is one of those weird things with t-testing and that nearly normal condition. We don't know what the data actually looks like other than the description of skewed to the right. But because the sample size is actually large enough, that satisfies the nearly normal condition. It's this weird balancing act once again. Large enough sample size is not a condition, but nearly normal is, so we'd have to look at the data. Oh crap, it's not nearly normal, it's skewed to the right. Well, if the sample size is large enough, then yes, we can proceed. It's one of these weird things. Is it large enough? Is it not large enough? Is it normal? Is it nearly normal? As long as it's one of the two, meaning the data actually looks nearly normal, which in this case it doesn't, or the sample size is large enough, then that nearly normal condition is actually satisfied. Again, very strange balancing act. I want to write some of this stuff down, so hold on. Let me flip my screen over. Let's see here. There. Wait, no. Yep. There we go. Good. So for this problem, okay, come on, you. Today is obviously the first. I'm just going to call this t-testing practice is what I'm going to call it, just for the sake of my notes right here. And this is number 11 off of that PDF that I gave you guys. In fact, I believe, hold on, let me double check. Yep. The PDF, I actually put the date on it. So, just for reference sake, the date is actually there. So good to go. So for this one, why is it okay for these data, or I'm sorry, to use these data for inference, even though the population is skewed? We'll draw a little picture here. Skewed data. Quote, nearly normal condition is needed to proceed. However, graph is skewed. Because sample size is, quote, large enough, it is okay to proceed with t-test or t-testing, whatever. I don't know what to call it. I think they actually have us running an interval in a few moments, but I'm just going to put t-test for the sake of argument. If the nearly normal condition cannot be fulfilled, it is okay to proceed as long as the sample size is large enough. But if the sample size is not large enough for most of these t-testing situations, then your data does have to be nearly normal. In a weird balancing thing here. I should get that chat open in my phone. Part B. The mean and standard deviation for the 60 companies in our sample was 22 days and 9 days. So, okay, hold on. I want to write some of this stuff down. Again, just for my own sake. This is part B for number 11. I'm going to show you what I'm writing down in a moment. There we go. Notice the notation that I used. Notice the notation that I used. This is a sample mean. This is a sample standard deviation. You want to make sure that you label it appropriately. Now, yes, I talked about this being t-testing. This is t-testing practice, meaning we're not going to have the population standard deviation. Let's just see what happens. Specify the sampling model, shape, center, spread, for the mean number of vacation days of such samples. Now, I don't know why there's all this like weird stuff from my mouse pad on my desk. Anyway, we can't use a normal distribution. We're not going to use a normal distribution. In fact, if I go to my calculator real quick, I'll just show you this visually. If we were going to use a normal distribution, you can see normal CDF right there, but that's not what I'm going to end up using because I don't have the population standard deviation. What I am going to end up using is this T distribution. I am going to be using this T distribution, T, CDF, inverse T. When you guys take your AP test, I don't believe you will be able to use the calculators on your computers. I really have to look into this. Okay, you see inverse T right here. The reason why I'm talking about this in this moment is because of inverse T. Look at this. Look at this. Come on. What do you notice? Say again? It's not there. Go back to my computer, inverse T. Go back to this calculator, it's not there. The TI-83s don't have it. There is a workaround for the TI-83s, which I'm not going to get into today. There's a workaround that's a bit more complicated. But having that inverse T is going to be very helpful. So if you do have a TI-84 that you're going to use on the day of the AP test, yay, happy day, good for you. You did it. But unfortunately, I only have the 83s unless I, threaten another math teacher. I don't really look like the type of person to be threatening someone. But I digress. Just, so you know, it's there. Look what happens when I go to TCDF, though. Hold on. Click. Look what happens when I go to TCDF. What do you notice is the difference between TCDF and normal CDF? Similarities, they both have lower and upper. But what's the difference? Let me go back and I'll show you normal CDF. Go ahead. Degrees of freedom. America. What does it not have? Yeah. Let me go here. Normal CDF. Boom. Mu and sigma. Which obviously we didn't have sigma in the first place. In fact, we don't even have mu. But when you go to TCDF, it's like, what the heck? They just want lower, upper, and degrees of freedom? America? Yeah, that's what they want. I'm going to show you how to calculate that stuff. Let me look at inverse norm real quick. Inverse norm. Inverse norm, you've used this before in order to find the Z star for your confidence intervals, where you would type in the area, the mu, the sigma, and then left, center, right. Typically, I keep it to the left, but again, you can change it, which depending on the circumstances. Look what happens when I go to inverse T. Oh, snap. They give you a lot less stuff. But it's incredibly helpful, and I am going to show you how to use it. Okay. Get back there. Back to this question. So what they want to know, they want you to specify the sampling model, the shape, the center, and the spread for the mean number of vacation days of such samples. Now, the sampling model, come on, thing, here we go. The sampling model that we're going to be doing, we are going to be using a T distribution. We are going to be using a T distribution. And we are going to be using this 22 as our anticipated mean. But there's a couple of things that you got to know. There's a couple of things that you got to know. And the best way that I can word this is by actually showing you the sample answer. The best way to visualize this is by showing you the sample answer. And I'm going to flip to that in a moment. Let's see here. Hold on. Where did it go? It's in here. There it is. Now look at this. I did not write as little as that for part A. I clearly didn't. They just said, we have a large sample size. Yeah, that's whatever. That's the sample answer that they gave you. But now look over here. It's a little difficult for the chat to see. I should zoom in on that. So let me actually rewrite this a bit larger so you can see what the heck is going on here. What they wrote was this. Okay, I get the 22, and I put the 22 in parentheses. What the heck's going on here? Typically, when we did sampling distributions using the normal curve, we would have sigma over the square root of n to represent that sample standard deviation. Ah, come here, you. The bottom of the snake fell out. There it goes. Or that standard error, I should specify. But we don't have sigma. So instead of using sigma, they're using S. What the heck is that? That's your degrees of freedom, yeah. Because again, as I said a couple class periods ago, I said this 3 class periods ago. There's only one normal curve. There's only one normal bell curve. But if you're talking T curves, there are technically an infinite number of T curves. There are an infinite number of T distributions. And each one depends on the degrees of freedom. So that's why they have to specify a little subscript on that T in order to indicate the degrees of freedom, because depending on the degrees of freedom, it's going to calculate a slightly different number. So that's what I'm going to throw there. Now, I left this up here for another reason. I wanted to look at these conditions right here. We already talked about these. There's one that we didn't talk about, which was the 10% condition, but I was going to get there. Randomization, yes. 10% condition, yes. Independence based on randomness, yes. Nearly normal. We know the distribution is skewed, but we have a large enough sample size to proceed. That's what we talked about earlier. I just wanted to specify that information there. So let me flip back. There we go. T sub 59, 22, comma, 9 over the square root of 60. The shape is a T distribution. The center, is a T distribution with 59 degrees of freedom. The center is 22, and the spread is 9 divided by the square root of 60. That would answer that question. Center, shape, spread. Go to here. There we go. Part C. Part C says to find a 95% confidence interval for the mean number of vacation days offered by U.S. companies. Well, first, I got to hit my assumptions and conditions. One of the things that we keep failing to realize is that if we want to use a certain type of distribution, whether it be a normal distribution or a T distribution, you need to hit your assumptions and conditions. If you don't hit your assumptions and conditions, then you have not justified your use of that particular distribution. So I'm going to say random sample stated. I can say that 60 is less than 10% of all U.S. companies. Hold on. U.S. companies. can say there's independence of number of vacation days offered per company. When I talk about independence, and I've warned against this, and I've left comments about this on a lot of those assignments, you can't just use the word independence and hope for the best. You can't just salute your paper and be like America. And yes, I know degrees of freedom. But you should specify the context of that situation. Now, nearly normal, we've talked about nearly normal a few times. Yes, this thing is not nearly normal, but because sample size is large enough, we can proceed. We are going to be using a t distribution, or in this case, a t interval. But again, you have to hit those assumptions and conditions. You absolutely have to. That's why it is a gift when the problem tells you, hey, assume this thing is normal. Assume the distribution is normal. Thank you. Thank you for that gift. If you give me that gift, then I can proceed without hesitation. But yeah, I need to hit those assumptions and conditions. Let me read what the question's saying one more time. They want a 95% confidence interval. Okay, hold on. I've written this down before. I want you to write it down again. This is how the t interval is calculated. This is how the t interval is calculated. Now, I'm going to do this two ways. I'm going to show you what the calculator automatically spits out, and I'm going to show you how to actually calculate that t star. Again, with my calculator, the 83 calculator, it's a bit more difficult than one would suppose, but, well, technically I could do that. You know what? I think I am going to show you how to do that. But yeah, I'll get there in a minute. So I'm going to have to calculate this junk. Okay. I'll go to my calculator on my computer. I'm going to go t interval. There we go. T interval. I have stats. I don't have data. I have a mu of 22. I have a sample standard deviation. Notice the S. Sample standard deviation of 9. And I have an n value of 60. Okay, that works for me. Let me make sure that this works as well. Hold on. Yeah. Okay. And then it's 95%. I'm going to calculate, and this thing pops out. Let me write this down real quick. 19.675, comma 24.325. With that X, that S, and that N. Okay. I'm going to go back to my question real quick, because again, this is something that I've noticed on some of your assessments. When you guys create the interval, and I got to double check the wording on this question, but sometimes they say construct and interpret. Then later on, like on a recent assessment that I did, I would say interpret, then I would also say explain what 95% means. Those are two separate questions. Let me see here. Find the 95% confidence interval for the mean. Okay, yeah, they didn't say interpret, but Part D does ask you to explain what 95% confidence means in this context. We'll talk about that in a moment. Let me make sure right here we got the right interval. 19.7 to 24.3. Yeah, nailed it. Let me just interpret it for the sake of argument. Here's the interpretation. We are 95% confident that the true number of vacation days, I'm sorry, I shouldn't say true number, but true mean. That's a better word for it. The true mean of vacation days offered by U.S. companies is between 19.675 and 24.325. That is absolutely sufficient. Let me see something here. Let me see this work the way it's supposed to. Oh, interesting. Yes, okay. I'm going to do something in my calculator real quick just to confirm one thing. And then I'm going to show you on the other calculator how it works. Heck yes. Okay. Nope. I want to use this formula. The way that this formula is set up is it is supposed to be 22 plus or minus some kind of a T star, which I don't know what it is at the moment, times 9 over the square root of 60. I need to figure out what that T star is. Now, in the past, you would have to figure out a Z star, but this is a T star. When you found out the Z star, you would have to use inverse norm. But in this case, we got to use inverse T. So I'm going to go to my calculator. I'm going to go to inverse T. Now, keep in mind, I'm finding a 95% confidence interval. 95% confidence interval. (95% confidence interval). What do I type in for area? Ooh. What do I type in for area? Huh? Say again? Not for the sample size, no. Not 0.95. Because remember, if we're trying to capture the middle 95%, the area that we're looking for these T stars is going to be the percentile. This should be 0.975. The reason for that is because, again, you're capturing the middle 95%, meaning you're not capturing the outside 5%, which is supposed to be split up evenly to the left and to the right. Meaning this is the 97.5th percentile. That's what I have to type in. And again, notice DF, you know it's degrees of freedom, 0.975. Degrees of freedom in this case are 59. Boom, there's my Z star. There is my Z star. Hold on. 2.001. Approximately. 2.001. There we go. That's what I would calculate. I'm going to do that on the calculator in a moment. Obviously, I'm going to get the same interval. I just want to see it actually happen here. So let's see, 22 plus, actually, you know what? Let me store that real quick. Let me store that to the letter T. There we go. And then I'll do 22 plus T times parentheses 9 divided by the square root of 60 There we go. Boom. And then I'll bring it back one more time. I'll bring it back one more time and change that plus to a minus. There we go. 19.675, comma 24.325. Clearly, it's the same exact interval. But that's how that T star would be calculated. It would be calculated in a very similar way that we did the Z star, except you would have to also include degrees of freedom. Now remember that number, that T star number, that 2.001 number. Now, this is not the only day that I'm going to show you this. I'm just going to show you this briefly today, and then I can go into more details another day. But how do I get that T star when that inverse T is not there? It's actually a very sneaky way of getting it. The sneaky way that I discovered that you can get it is this way. I can go over, actually, let me reset my calculator real quick. I can go over to T interval, stats, a mean, what was the mean, 22? Standard deviation, well, actually, you know what? No, I'm going to keep the mean at 0. And I'm going to change the standard deviation to this. What the heck did I just do? What the heck did I just do? Holy crap. Mr. Markey, spouting off all this garbage. That's a T. I want an X. Anyone see what I typed in for S before it turned into a decimal? I typed in the square root of 60. Here's the reason why. What happens to that fraction? Just becomes a 1, right? And it goes away. And the 0. So basically, 0 plus or minus T star degrees of freedom. By running this with a mean of 0, the proper sample size, which, by the way, N is 60, which means that forces that to be a 59. By running this sample size, that mean, that sample standard deviation. Look what happens when I calculate. Again, this is not the only day I'm going to show you this. Boom. It's a workaround to get a T star. My calculator doesn't have inverse T, but I can fool the calculator into giving me T star. It's really messed up. We'll get into those details again another time. Weirdness. Did I ever tell you these calculators can talk? No? Remind me to show you that one day. These are really insane. There's actually a talking mechanism on the inside that was designed back in the 90s, but they didn't finish it in time for mass production. So they didn't really have any type of speakers externally. But there are some sort of internal speakers that when you get to the right command, it actually does do like a rudimentary kind of like weird, gruff computer sounding voice. Nothing? All right, whatever. No one believes me anymore. I'll be the one laughing when I show you. Have I never showed you that before? You're nodding yes. I have? Forget you guys. Anyway, back to this. Where am I? Explain what 95% means in the context of the problem. Again, something that kind of goes back to, I'll do it right here. Something that, come on, you. something that goes back to what we did, part D, here we go, on the actual major. 95% means that in repeated samples of similar size, 95% of constructed intervals would capture the true mean of U.S. company vacation days offered. I kind of wrote that out fast, but it's the general definition that we've always given it. Repeated samples of similar sizes, 95% of the constructed intervals would capture the true mean of U.S. company vacation days offered. Put it into the context of the problem. The context of the problem. The context of the problem. I want a t-shirt that says context. And then people are like, what does that mean? And I'm like, oh, you don't know the context. And then I'd laugh and slap my knee a bunch of times. I don't know. All right. Huh? Well, they look at me funny normally, you know, like that. Anyway. Goodness gracious. You know what the funny thing is? When people ask me, they're like, oh, what do you do for a living? I'm like, oh, I'm a teacher. Oh, what do you teach? I teach math. And then their immediate reaction is disgust. Just disgust. They're like, oh, math. I hated math. Like, what would you have said if I said any other subject? You know, come on. I teach art. Oh, I love art. Well, yeah, it's cool. You need math for it. Anyway, back to this. Number 12. Now, this one, I'm going to give you a small opportunity to get some of the things done with it. So the use of a calculator is definitely needed for this problem. I want to make sure that you realize that. So have your calculators ready because you're going to need it for this problem. A father is concerned that his teenage son is watching too much television each day. Since his son watches an average of 2 hours per day, his son says that his TV habits are no different than those of his friends. Since this father has taken a stats class, he knows that he can actually test to see whether or not his son is watching more TV than his peers. The father collects a random sample of television watching times from the boys at his son's high school and gets the following data. Is the father right? That is there evidence that the other boys average less than 2 hours of television per day? Conduct a hypothesis test, making sure to state your conclusions in the context of the problem. Now, I'm going to do the first part of this with you. And then, like I said, I'm going to set you off on your own to see if you can finish the hypothesis test. So, again, you may need a calculator in order to do certain things. So first, this is number 12. Null hypothesis versus alternate hypothesis. Going back to the problem. The father suspects that his son is watching too much television. So then he gathers all of this data. Let me write out what the null and alternate should be, and then I want you to kind of think about why I did that. Not a typo. A lot of people see that and they immediately think, Mr. Markey, you made a mistake. Shouldn't it be greater than 2? No, it shouldn't. There's a reason why. There's a reason why. The son is saying that 2 hours of TV is no different than his friends. The father believes his son is watching way too much television, which automatically makes people think you got to do greater than. However, the data that the father collects is from from his son's friends, the boys at his school. The father wants to know, okay, is the sample data that I collected significantly less than my son's TV watching habits? Because if I can prove that the other boys at school watch less television, then I can conclude to my son, hey, son, stop watching TV. Here's my statistical evidence that you don't understand. I don't know. But this is what you're going to be setting up. So I want you to take the next little block of time, and I want you to go through the rest of the hypothesis test. I wanted to make sure I got this set up correctly. I want you to write out your assumptions and conditions. I want you to perform the appropriate test. And when I say perform the appropriate test, you're going to be performing a t-test on the calculator. That's why I said you needed the calculators. You're going to be performing a t-test, so don't worry about having to calculate any of that stuff by hand. But then you're going to come to the appropriate conclusion based on the p-value that it spits out. Let's take the next block of time. Knock it out. Okay. I'm going to run through some of this right here. I don't think you guys will ever, I don't know when this actually stopped being a thing, but I don't know if you guys have ever truly experienced a perfect Saturday morning where you get to go through the TV guide and select the shows that you will watch, because there's no such thing as YouTube and DVR. Just saying, it was a wonderful time back in the 90s. You all suck. Anyway, back to this. I'm going to calculate real quick something just for the sake of argument, because I am going to be doing my assumptions and my conditions. One of the assumptions and conditions is the nearly normal condition. And if I'm talking about nearly normal, then I need to make sure that the data that I have looks nearly normal. Now, before, we were able to get away with it because of the US companies. We sampled 60 of them. That was large enough. But this guy only sampled 10 kids. So that's definitely not large enough. I need to look at the histogram. So I entered my data into L1. I went to plot 1 and I turned it on and I turned it to a histogram. I zoom 9'd it, and like a big middle finger, there is the normal distribution, or what's nearly normal. It looks close enough. That is one of the assumptions and conditions that I have to talk about. So please make sure that if your sample size is not large enough, you have to look to see that it's nearly normal. So now I go in my assumptions and conditions. Go back to the problem. The father collects a random sample. Okay. So let's see. Random sample stated. I think before I said that he sampled the boy's friends, but I was mistaken when I said that. Nowhere in here does it say that the father sampled his friends. It says that he collected a random sample. And that is important, because obviously if he's sampling the kid's friends, that data could be biased, considering the fact that if they're friends, they probably have similar TV watching desires and needs and things of that nature. Maybe they watch the same stuff. But since it's a random sample, I can say independence of TV watching habits is reasonable. Again, I'm putting that into the context of the problem. Now, I still have to talk about the 10% rule. Sampled 10 times from boys at the son's high school. All right, well, 10 is less than 10% of male population at high school. I'm going to assume that there's more than 100 boys at this high school. Cool. Nearly normal fulfilled. And I can show that by including a little sketch of the distribution and showing that, yeah, it's nearly normal. It's got that bell curve. Looks pretty good. So I'm going to be using a t-distribution, or in this case, a t-test. So I'm going to go to my calculator. I'm going to go over to t-test. Now, there's a couple ways you can go about this. With t-testing, you're going to need X bar. With t-testing, you're going to need the sample standard deviation. So on my calculator, I am going to have to run a 1var stats. If you run that 1var stats, that'll give you the information that you need. That gives me X bar at 2.01 and S at 0.345 or some junk like that. Make sure you're writing down the S. Now, I believe that when I go to t-test, I believe that that X bar and that S should automatically be transferred over. Fingers crossed. Heck yeah. Look at that. X bar and S automatically in there. My mu is 2. Oh, which, by the way, look at this. What do you notice about the average of these boys' TV watching habits? What do you notice? What's the average of the boys? 2.01? What's so weird about that? What's so weird about that? It's already more than what the kid watches. It's already more than what the kid watches, which means that I'm going to get a ridiculous p-value here. Notice I changed the alternate hypothesis right here to be less than. Look at that p-value. Heck yeah, failed to reject. Again, I'm going to verbalize this because I'm out of time. I failed to reject the null hypothesis. The father does not have enough evidence to show that his son's TV watching habits are more than any of the boys at school. And you could say because the p-value is greater than 0.05. I am going to ask for the multiple choice, like I said at the beginning of class. There'll be an ungraded assignment for that. And I will also produce for you the answer key. Trying to think if there's anything else. I don't think there is because the bell's going to ring right about now. So I'll see you all in a couple weeks. Woo! If you haven't left a comment in the chat, please make sure you do so. I'm going to leave it open for a few more moments. Everyone needs this break. Thank you too. See you. Thank you. See you. Thank you. See you. You too. Thank you. You too. Bye, guys.